Hey gang, today we're going to talk about conservation of momentum. Conservation of momentum means that when objects collide, like come together and hit each other, or when objects push apart, like those videos of the students that push each other apart on carts, or in cases of explosion, we say that the momentum is conserved in those collisions or explosions. And when we say that conserved, it means that the total momentum remains the same from before they collided to after they collided. You can kind of represent it this way. The total momentum, remember momentum is represented with a P, and equals after. You can kind of take this as an example. Let's say like grandma was roller skating at the roller rink with her grandkids, and this little boy was not moving on the roller rink. Grandma has a certain amount of momentum because she has mass and velocity. So this is how much momentum she had. The little boy doesn't have any momentum because he's not moving. So his momentum 0. Afterwards, when she picks him up, that boy picks up some momentum. He starts moving. But grandma, she probably slows down when she picks him up. So her momentum actually reduces a little bit. But if we compare the momentums from before and after, we can add up these amounts. And we end up with something like this. So before, we would say that the total momentum is 310 because 310 plus 0. But afterwards, if we add these momentums up together, we have 230 plus 80, we end up with the same number. So we say that the momentum is conserved between the two sides. Whatever momentum you had on one side equals the momentum you had on the other side. We're going to look at examples of how we solve out momentum problems. But when we solve them out, they can be a little tricky. Here's how you solve them though. When we read through a problem, you read and visualize the problem in your head. So you kind of are trying to make a mental picture of what's going on. And then on your paper, these are going to be the things that you write down. You write down before and you write down after. And we're going to keep them a little divider between those two things and say like one side over here on the left means before. One side over here on the right means after. You're going to draw a picture or pictures of what's happening before. It usually involves two objects. So you draw your pictures of what's happening before, and you draw pictures of what's happening after. And then we write out momentum total before equals momentum total after. We list each momentum before and list each momentum after, and we solve for some missing things. It is a little easier once you see it, but these are going to be problems I want you to do on your paper, and you're going to hand them in as part of your assignment. Because it's more, as you kind of go through and do it, you kind of figure out the groove to get into and how to solve the problem. As we do this though, some things to keep in mind is that momentum, it is a vector, and it can be represented with positive and negatives. But those things that are positive and negative do mean directions. So something you have to pay attention to some directions that are given in the problem. Like something moving to the right is positive. Something moving to the left, though, has a negative, or would be negative. It would have a negative momentum. And if they tell you a positive momentum, like it's labeled as positive, and then that means it's going to the right. If it's labeled as negative, it's going to the left, but you have to interpret these things. And then if it's not moving at all, we can say that the momentum is 0. So those are some things that we can assume and we can figure out. There are going to be some things that we do have to figure out at the end, because we can't always assume that at the very end of the problem, everything stops. And so we have to solve that out. You'll see that here, okay? So this problem, a van is traveling east with a momentum of 1,500 kilogram meters per second, collides with a car moving west with a momentum of 800 kilogram meters per second. So I'm kind of picturing that in my head. I have one car moving to the east and one car moving moving to the west. As they collide, they stick together, and the van has a momentum of 500 kilogram meters per second. What is the momentum of the car? So when I do this, I'm going to follow these things. I read through them, kind of visualized what was happening, and I kind of want you to do that as we're reading through it. We got right before, after, draw pictures. And so here we go. So up here at the top, I'm going to write this out before, and oh boy, I am writing with the mouse right now. So we got before, and so there's going to be some things here later I'm going to abbreviate, but my stylus died out on me. And here's my after. And let's just make this a little bit more clear. There we go. So we have before, after. Again, we're going to kind of keep a divider line between these two. We're going to say whatever happened before and after. But in our problem, we also have these two vehicles, a van traveling east and collides with a car moving to the west. So when we say before, it's before they collide or before that thing happens. So I'm going to draw a van. And your pictures, they do not have to be fancy, because if you look at my pictures, they are definitely not fancy. But this one, we say we'd go to the east. It's kind of like going to the right. And then it collides with a car that was also moving, but it was moving west. And it has this momentum. So exactly how to draw out that momentum, we can worry about that stuff later. But we have one van going to the east and a car going to the west. Here's what's happening before they collide. And when we say after, it's after they collide. It says that they stick together, so it's like they're smushed. So I'm going to draw that, and you can kind of make this however you'd like, but let's say that they kind of smush together like this. And then they kind of start to move together when they collide. Right? So they're all kind of discombobulated. But then, what is the momentum of the car? So we did this, we wrote before and after, and now we're going to write out, we drew our pictures before and after the collision. Now I'm going to go and write out my momentum total. So I'm just going to do this. Total momentum before is equal to the total momentum after. And I want to write this out this way because I'm now setting up my equation. My total momentum on the before side equals total momentum on the after side. And now I write out and list each momentum on their own. And that means for each object. So I'm going to do a momentum for the van and a momentum for the car. On the other side, I really have the same thing. I need to list out the momentum for the van and a momentum for the car. But the difference between these is that one set of numbers is going to be from before they collided. One set of numbers is going to be from after they collided. And just kind of a reminder, on your sheet of paper, I want you to make sure that you're writing it down and writing it down this way. A lot of our problems kind of work down, kind of downwards, and you'll kind of see how that works. But we want to make sure that we're listing out all this information. It's really kind of a line of reasoning that we're using. We're saying before they collided, after they collided, draw our pictures out, what's actually happening so that we can visualize what's going on, and then actually figuring out what that total momentum is before and after. And we'll solve for the thing that we don't know. And so here we go. Now that I have this, I'm going to list my momentum of the van, but it has to be from before they collided. So when I read through this, it was like before they collided, oh yeah, they said that the van was traveling east with 1,500 kilogram meters per second. The unit I don't have to worry so much about, but this 1,500, that represented this. And because it's going to the right, it's also positive. So I'm going to just keep it positive. I'm checking for that as I'm going. Plus the momentum of the car. When I check this one, it says that the car was, before they collided, had a momentum of 800 kilogram meters per second. So that number is important. But this time, this car is going to the left. So it's not just 800 kilogram meters per second. It's negative because it's moving left or to the west. Okay? So that's kind of a key thing. Equals the momentum of the van in the car. This momentum of the van, it's not the same number as over here because now this has to be after they collided. So the momentum of the van, and I read through it, it says after they collide, they stick together, and the van has a momentum of 500 kilogram meters per second. It doesn't tell you which way it's going, but because they have it positive, they don't have a direction next to it, we can assume that it's just going to the right. So I'm going to write out 500. On this side, what is the momentum of the car? So this is the thing that I don't know, and I kind of have this. So momentum of the car, And now when now I have my equation set up. This is the trickiest part of the problem, is getting it set up to this point. Because if you can get it set up to this point, doing the math is really easy. But you have to go through this process of setting up before they collide, after they collide. Draw pictures of them before and after. Saying that the momentum before, total momentum before equals the total momentum after. And then saying what the momentum of each object is before and after, putting numbers in. And now we're going to actually solve it out. So this doing the math, or you want to make sure that you have this part first. So if you need to go back and check it out, you can rewind the video. But once you get to this point, we're going to solve it. So now with the numbers, we're just going to take these numbers, and it's like an equation. Here's the equal sign, and we're going to combine these together. 1,500 plus negative 800. We end up with, do that, it's 700. Equals, we have 500 plus the momentum of the car. And now when we solve this one out, it's going to be, to get the momentum of the car, I have to undo things on this side to get it by itself. That means I have to subtract 500 from both sides. Again, writing with the mouse, not that fun. But on this side, the 500s go away. This side, I have 700 minus 500, I get 200, and it's kind of squeezed in here at the bottom. But in the end, what I really end up with is that momentum of the car is equal to 200. My units, because this represents a momentum, it's just this kilogram times meters per second. Now really quick, when we end up solving this out, there's a couple things you want to check for, is what does this actually mean? So we solved out for the momentum, and it came out to be positive. And because it's positive, that means that the car is actually moving to the right. And it has some momentum. But this makes sense because the van and the car, when they actually collide together, both of them should be moving in the same direction. Not necessarily with the same momentum, but into the same direction. So this is going to the right, the van was going to the right. Yeah, that makes sense. But that's kind of how you solve out these problems. You go through the process, and getting up to this point right here, this is the tricky part. And so make sure that you review this problem. If you have questions, you can always go back. All right? We'll see you in the next video.